welcome to our session on fighting wildfire with artificial intelligence. Today I'll be presenting together with Gabe Micah from San Diego Gas and Electric, a division from Sempra Energy here down in Southern California with over 3.6 million customers. My name is Rolf Gibbles and I'm heading up the global business development at Amazon Web Services. At AWS, we focus on power and utilities, and I will give you a short introduction and put this topic in context of our overall strategy and work in the power and utility space. The electric power industry is going through tremendous change. Many are driven by the rise of wind and solar, and at the same time, major decarbonization efforts around the world. Many utilities have goals to reduce their carbon to net zero by 2040 or 2050, respectively. External and internal disruptors all lead towards the need for digital transformation and a diversity in systems across generation, delivery, and demand. External factors can include, for example, wildfires, like the session we have today is a very critical factor. Other extreme weather conditions, the rise of electric vehicles coming as new loads to the grid, increase in more and more distributed energy resources, and then even in states like California, the requirements to have new cars and passenger trucks to be zero emissions by 2035. Internal disruptors that often drive change, for example, can be chronic and systemic existence of silos, like data silos, people silos, process silos, not allowing effective collaboration and innovation. Sometimes a poor compliance and safety culture can drive those internal disruptors or create them. An aging workforce, which needs to be followed by younger talent, is a big disruptor, and we need tools to attract those young talents. In my group, these factors drove the creation of 5 solution categories. They are IT and OT transformation, work and asset optimization, energy supply transition, and customer engagement. In short, really all these changes are driven by the 3Ds. The 3Ds are the decarbonization, decentralization, and digitalization happening in the industry now for a while, but there's a lot more work to be done. Just to give you some examples, around IT transformation, for example, SAP migrations are critical. Call centers to modernize those, to make them allow people to work from home. IT agility. Around OT transformation, media data analytics is a big topic. IoT analytics for distributed energy resources. Work and asset optimization. We talk about vegetation management, remote inspection, workforce crew optimization, and predictive health, predictive equipment health. Work and asset optimization. We just talked about, this also leads into the energy supply transition around market forecasting, market optimization, integrated microgrids, peer-to-peer energy trading, using, for example, blockchain technologies. And then customer engagement is very important around using connected home, smart home, tied into demand response programs, improve customer care, improve digital user engagement. And all this is underpinned by the core functions of AWS services and the various categories around those: security, IoT, AI, ML, and also very important, our close link to Alexa for communication inside your home. With that, I would like to wrap it up and hand it over to Gabe, but I want to make sure you all understand partnerships are critical. Partnerships with our customers, partnerships with system vendors, and partnerships with our major system integrators, our major ISVs, and many, many thousands of startups who do a lot of creative work in this space. With that, I want to hand it over to Gabe for his topic. Thank you.
Thanks, Rolf. Welcome, and thank you for joining. When I think about AWS reInvent and I think about the future, it's extremely important that we have communities and conferences like we have here. A global community looking toward the future, discussing emerging technologies that have the potential to transform how we work and live, and collectively discussing and acting to solve some really tough problems. And in the spirit of collaboration, I'm here to talk a little bit about our story at San Diego Gas and Electric. And it's not just about what we're doing with emerging technology and not necessarily how we do it, but more importantly, I want to talk to you about why we do it. Now, about us. We started out as the San Diego Gas Company in 1881, serving 3,000 customers, and shortly thereafter began to deliver electric service, which has now evolved to what we are today, nearly 140 years later, serving 3.6 million customers. And I picked this background image of our Energy Innovation Center as a contrast to where we began to where we are now. But why innovate? Why at a company that's been around for close to 140 years? Why think differently? Why does it matter? And when you start to think about business strategy, there are a couple of things that you really want to pay attention to in order for your business to be resilient. First, you must have the ability to sense change. And second, you must have the ability to adapt to that change. And change can come in many forms. It can be changes in technology, market, and regulatory. And one of the largest drivers of change over the past decade for us has been climate change. And I'd like to start the story by acknowledging the current state of the business, because our business is changing and it's changing fast. And we are, in fact, in an exciting but challenging time for the industry. On one hand, we're facing increased risk, and these risks are testing our business and systems resilience like never before. On the other hand, we're in the midst of a major transition to a cleaner, more complex energy future with a wide variety of energy sources. And one of the largest changes that has driven our behavior over the last decade has really been around climate. And if you were around during the 2003 and 2007 fires in Southern California, or the recent fires up and down the West Coast, you know that these are significant events. And they have fundamentally and radically improved our approach to wildfire mitigation, fundamentally changed the technologies that we invested in, and fundamentally changed how we think about our role in the safety of the communities that we serve. And at the end of last year, SDG&E released a 28-minute documentary titled Everything in Our Power, detailing specifically what we've been doing to combat wildfire in our service territory over the past decade. Let's take a look at the 2-minute version.
When I walk out my back door and I look up into the hills, I see devastation.
Fire is a real concern here.
The fire season's gotten longer. The fire season's gotten hotter. We're seeing fires do things that we've never seen before.
Pretty powerful video, and even more powerful if you've lived through these events or have been impacted by them. And for me personally, this is the primary reason that I'm so emotionally attached to the company's mission, because it allows me to play a role not only in helping SDG&E achieve its mission, but also to help improve the safety of my community. In November of last year, due in large part to a lot of the technologies and projects that we've invested in over the past decade focused on wildfire safety and electric reliability, SDG&E was recognized with PA Consulting's Reliability One Award. And that doesn't come at a small cost. Since 2007, the company has invested $1.5 billion in fire risk mitigation. And not only are we working to harden the grid, but we've established a world-class fire science and meteorology team that crunches terabytes of data from 230 weather stations every single day to inform our wildfire risk reduction model. And one of the most strategic investments we've made recently is to fly drones over our service territory to identify damages that may lead to wildfire. And although we've made great strides and in hindsight made some really smart investments, the rate of business change that we've seen has outpaced the ability for technology to support all of the business's needs. Whether or not the technology didn't exist, or it was too hard to implement, or we didn't have the talent to support it, the truth of the matter is there's been a gap. And I would submit that this problem is not unique to our company. But advances in digital and technology are helping to close that gap with the likes of automation, analytics, natural language processing, machine learning, and extended reality technologies. So over the past couple of years specifically, our objectives became very clear: to accelerate the implementation and adoption of new and emerging technologies to effectively close that gap. And we see that path to maximizing value through these changes is through continuous and high-frequency innovation with technology. And by high frequency, we mean having an unwavering dedication to continuously testing new and emerging technologies to determine if and when we should invest in these emerging technologies to drive our transformation. Now, the real question is, how do you actually close the gap? Can you ever close it completely? From a cost-benefit perspective, do you ever really want to? And while we don't have all of the answers, I want to step you through the innovation framework that we use to rapidly test emerging technologies with the intent to have a point of view or perspective on future technology investments. And while we were building out this innovation framework, we knew two things. One, we needed to increase the frequency in which we tested out emerging technologies. And two, just by the very nature of emerging technology, we knew we wouldn't have the internal staff experience with these new capabilities and that we would need to bring in talent. And our innovation framework looks like this, which is 3 basic steps. It's not very complex, pretty straightforward. The hardest part was just getting started and increasing the frequency in which we did this. And while we have a list of potential technologies that we would like to test from a digital perspective, what really drives what we explore begins first with the line of business. And let me explain a little bit about how our digital team delivers services. First, we deliver horizontally across all lines of business. And second, within each line of business, we deliver a stack of specific technologies that we've optimized to deliver at speed and scale. And if we don't have a capability that will solve the business problem, we make an investment to explore this process together, side by side with the line of business. Learning is all about rapidly learning together, 6 to 8 weeks total. And while we focus on using Agile methodologies, Agile doesn't necessarily mean faster. We see Agile as prioritizing the most important thing at the right time. So the example of the anti-pattern is how we've traditionally delivered service, with big monolithic projects that last 6 months or a year, with no guarantee that it's going to be fit for purpose. And the value-driven approach is all about delivering some sort of minimum viable product as early as possible to demonstrate value, then iterating on it. And there are 2 things that allow us to be successful during this process. 1, we bring in the experts of the technology we're trying to test. And 2, we use human-centered design to bring that subject matter expert or person impacted right into the middle of our design process. The proof step is pretty straightforward. It's all about business value. If it isn't helping us close the gap, we would question whether or not it's a good investment. What we wanted to show here is that we've built a strong foundation with analytics and intelligent automation. And what we're seeing now is our greatest opportunities to drive business value and to close that gap lie with these new and emerging technologies. So once we've decided something is ready for the enterprise and that it will drive value, we scale through what we call the digital factory with 3 main components: backlog, build, and operate. The backlog is all about demand management and having opportunities that have the potential to close the gap. Build is completed through the use of modern techniques and modern platforms like DevOps and cloud. And we see scale as the intersection between how fast we can deliver and how fast the line of business can consume that specific service. And that point where they meet is the velocity at which we deliver, which we refer to as capacity. And the capacity at which we're delivering in the cloud today is 20 internal mobile and workflow applications a year, 16 analytics projects a year, 12 emerging technology innovation proof of concepts a year, and 20 to 30 computer vision models a year. Now let's get into the specifics of what technologies we've tested through the Learn, Proof, Scale framework, and more importantly, what we see as the key enablers for our innovation in the future. And since we're here at AWS reInvent, let's start with cloud. Our investments in digital and cloud will give us access to the most advanced digital tools available to fuel our innovation, because there are certain strategic elements that are truly inherent to cloud, like artificial intelligence and machine learning. And those investments will, in turn, enable the organization to realize the art of the possible, and doing so in the high-frequency fashion I talked about earlier. This section will specifically focus on the business value we're seeing through emerging technologies to fight the risk of wildfire. And in using cloud services, we're increasingly looking to emerging technologies like AI and ML with new data sources from drones and satellites to better inform, with a higher level of certainty and precision, which segments of our system have the highest risk of a wildfire. And as I walk through each of these stories, you can start to see how they build on each other to better inform our decision-making process to better mitigate against that risk. From a weather analytics perspective, we've installed 230 weather stations throughout SDG&E's territory, which gives us the ability to correlate multiple factors like wind speed, temperature, humidity, topography, and fuel conditions in order to identify areas in our service territory that have a higher likelihood of fire. By using the power of AI and analytics as we go into a red flag high fire threat event, we can more accurately predict which communities will be affected, and we can proactively de-energize certain sections of the system to ensure that we limit the customer impact and ensure the safety of our employees and our community overall. And this is our primary tool as we go into red flag extreme weather events. And this is also the primary tool in which we initiate our processes for public safety power shutoffs or PSPS events. I'll spend a little bit more time on this next section as we walk through our computer vision capabilities that are built on top of AWS. SDG&E's drone inspection, assessment, and repair program began by flying 30,000 poles in our Tier 3 high fire threat district areas in the second half of 2019. We now have over 1 million drone images and expect to have almost 3 million by the end of next year. And we needed a capability to quickly analyze these images and prioritize damaged assets that have a higher likelihood of leading to wildfire. By working with our innovation partner, Accenture, we are now implementing machine learning models to automatically detect damages coming in from the drones, which is complementing and additive to our weather prediction models, allowing us to be even more precise on which circuits have the highest risk going into a red flag high fire threat event. I'd like to share a quick video demonstrating this technology and where we are taking it in the future.
At SDG&E, we have an innovation program and a framework that enables us to rapidly test new and emerging technologies to inform future technology investment decisions. And in the case of the drone investigation, assessment, and repair program, we asked ourselves the question, how might we analyze thousands, if not millions, of images coming in from the field to automatically detect a damage on the electric system? And the emerging technology we identified to answer that question was artificial intelligence and machine learning. Machine learning will enable us to train a computer to augment the existing manual evaluation process. As images are captured by drones in the field, they are then uploaded into our central portal, and the qualified lineman reviews every single image and manually annotates any damage. And when damages are manually identified, we simultaneously train our machine learning model by drawing a bounding box around that damage, which is then used to identify those same patterns in future images. And what we have in the end is this amazing human plus machine relationship where we can be much more efficient and effective in the long term. This capability can now enable us to identify damages faster, prioritize the issues, and initiate work in the field. Additionally, we are now exploring other scenarios such as deploying a machine learning model on a mobile application for our qualified linemen to utilize in the course of their daily work. And we have a long-term vision where we might look to implement these capabilities on fleet vehicles or other company assets so that we can detect damages across the service territory on a regular basis, allowing SDG&E to continue delivering clean, safe, and reliable energy to the communities in which we serve.
Our computer vision capability, which we refer to internally as Intelligent Image Processing, or IIP, is a serverless, containerless application utilizing PaaS managed services on AWS. And our current strategy and approach from an enterprise perspective is to leverage similar serverless patterns and try to avoid the certain elements of complexity that come with spinning up compute and other services that require more overhead and support from a patching and maintenance perspective. We've taken it a step further, where we've blacklisted spinning up compute and other non-managed services that aren't immutable and driven by our infrastructure as code standards. Let's talk a little bit about the process. So we start out on the left by bringing in two sources of data into our S3 buckets. The first is the actual imagery coming in from the drones, And the second is all of the contextual data from our asset management system, which contains the pole information, the location of the pole, and what's on the pole. We then prepare the data and resize the data for inference with recognition custom labels. That's where the actual prediction occurs to determine the asset and any type of damage associated with that asset. After we store the results from the inference in the database, we then present the data out through our UI layer utilizing Amplify, so our qualified electrical workers can then validate the predictions. And we deploy all of this using our fully automated CI/CD pipeline with CloudFormation templates. Let's talk a little bit about how we structured our efforts to detect damage on the system. Our Agile persistent teams have developed a centralized enterprise image repository as well as machine learning models for rapid imagery analysis. And the image repository currently stores 1.2 million images from drones in an AWS S3 bucket, which can be visualized by distribution pole on a map-based geospatial user interface. And through that work, we can now detect 25 unique asset and damage conditions in imagery through AWS's recognition custom labels. And the UI allows you to visualize model predictions and provide feedback in the form of approvals or rejections. So approvals positively reinforce the model, and rejections provide our data scientists with insights on how to optimize model accuracy over time. And we are extending our capabilities beyond distribution asset identification. Through the use of our Learn, Prove, Scale framework, we asked ourselves the question, how might we identify communication providers that attach to our poles using artificial intelligence? The solution we used has three main components. First, we built an object detection model to identify tags and equipment that are provider specific. We also use OCR to detect text or numbers, which are additional indicators of a specific provider. And when no unique identifier is present, we then use computer vision to identify where on the pole the provider is attached and combine that with business logic to infer the presence of a specific communication provider. And we plan to scale this capability in the next few months to help us communicate with these providers when we detect a damage on their system that may contribute to a wildfire, ultimately to help increase the safety of our communities. And we are now planning to test and learn about how we can incorporate satellite imagery and artificial intelligence to further inform the risk of our circuits based on near real-time analysis of vegetation encroachment of our electric system. So why now if satellites have been around for a long time? And it's primarily due to the proliferation of these low Earth orbiting satellites, which have really opened the door to near real-time, high-resolution data that can be used to detect vegetation height and proximity to the electric system with a high level of accuracy. And the intent is to take all three of these use cases, weather analytics, drones and computer vision, satellites and vegetation encroachment, to make really good decisions as we're going into a high fire threat event to reduce the risk of wildfire and to limit the customer impact. So we've been focused on exploring how we use technology to prevent a wildfire, and we will continue to have a laser focus on implementing preventative measures. But we also know that fire is not something we can always control. So if we need to initiate a public safety power shutoff or PSPS event, or there's a wildfire in our service territory, we want to equip our customers with the information they need when and where they need it. Wildfire and the potential for wildfires create stress and anxiety, and our customers need information so they can prepare and act to protect their families and businesses. So we asked ourselves, how might we help customers access the information they need through the channels they prefer? And to respond to that, we are now building an Alexa skill in a mobile application that leverages our weather data and analytics, fire protection index, outage data, notifications, community resource information, as well as other contextual data to provide our customers with the critical information they need to stay informed and safe. And when you have AI and humans together, it's really important that we think about this intersection between our employees and these new emerging technologies. We know it first starts by reimagining work. And the more we dig into these technologies, the more we realize that in a lot of ways, we are limited by our own imaginations, and experimenting is a good way to sharpen your vision of what can be. It also includes reskilling employees. That can go a couple of different ways. One, we need to attract, build, and retain more talent that can harness the power of these technologies to build these capabilities within the organization. And two, we need a tremendous amount of organizational change management for the folks consuming these technologies and interfacing with these technologies. And preparing the org is really about bringing the organization along. It's one thing to operationalize a couple of use cases with a select group of folks, but completely different when we're talking about these capabilities being pervasive throughout the company. So to summarize, we've talked through in detail how we use artificial intelligence to increase our system resilience, reduce the risk of wildfire, reduce the customer impact, and increase the safety of our communities. We've also talked a little bit about how we're working to better inform our customers during an actual event. And you could start to see that our recent investments in cloud are empowering our company to drive greater societal value through these new innovations. Because we see this as our collective future. And this is how we deliver energy with purpose to our customers, to our colleagues, and to the communities we have the privilege to serve. Thanks for watching.